Hello everyone. This video is focused on providing basic information about India Urban Data Exchange Platform, IUDX. IUDX consists of three submodules or interfaces. A catalog interface used for search and discovery of resources within a city. A resource interface used for obtaining data from a particular resource in a city. An authentication interface used for obtaining authentication token for accessing secure datasets of a resource. Let me explain in detail about these three resources available in IUDX. Catalog interface. The catalog interface consists of the metadata of the resources such as its ID, description about the resource, tags, geolocation for a static sensor, data model, provider of this resource and their information, the API objects and the APIs through which you can access these resources. Using the catalog interface, an application developer or a user can discover resources available using the APIs which allow you to do a search using attribute and geo queries such as tags, description, geolocation, the provider of the resource, etc. Next is the resource interface. The resource interface contains the actual data for a resource. It has search and count APIs based on temporal properties, geo properties, and attribute based queries. The users and app developers can use the search feature of the resource server interface to construct complex APIs consisting of attribute based geotemporal queries along with attribute filters to fetch data from a particular resource. Next is the authentication interface. IUDX authentication service allows owner or provider of a resource to set access control policies. For users or app developers, it allows obtaining a token. Both the operation requires a valid certificate provided by the IUDX CA. With the authentication interface, users can access protected datasets by obtaining access permission from the data owner. Further, in this video, we will focus on using the IUDX system with example APIs using Postman and also using the SDK called PyIUDX. The API documentation for IUDX is available at apidocs.iudx.org.in. We have classified the API documentation to three specific sections, one for catalog, one for authentication, and one for resource server. Each section has a description about the specific API, the parameters that we need to pass in, along with the options that it has. We also have included certain code examples for the following languages, for example, Java, JavaScript, Python, Go and curl. So whenever you want to try certain things, make sure that you replace the resource server IP with the specific IP that you are dealing with. Along with that, you should also change the ID of the resource, which should be corresponding to the ID that is available in the catalog. So let me now take you through certain examples that we have using the IUDX application that we have built, mainly the catalog and resource server based UI that we have. The one that we have is basically the IUDX UI app. We have a discovery of resources for the Pune instance being shown here. We have close to 851 resource items with 4 providers. This user interface application has two views. One is the list view, another one is the map view. You can access the map view by clicking on this particular geoquery interface here, which will take you to the map page. Let me take you through the example that is specific towards searching and discovering a pollution item, trying to access its data, figuring out its data model, and then looking at its API objects as a part of this tutorial. So let me start with the list view that we have. So as I explained before, the catalog has ways to discover resources. Here I am using the attribute search available in catalog using tags. Using the tag based search, I am trying to look for pollution related sensors available in the city of Pune. So once I search it, the API call has been made to the catalog server, which responds with all these datasets available. I can say there are close to 62 results for the tag search called pollution which I made. I can look into the details of these particular sensors by clicking on the details tab. It gives me the resource ID, the description, and other information such as the provider of the data. This information is useful because in case if there is certain secure data available for this particular resource, we need to go and get access permission for that particular sensor in order to go further and obtain those certain fields. For example, the data model tab available here will give us information about the data that is being sensed by this particular sensor. For example, this particular pollution sensor senses air pressure, and the unit of this measurement is a standard atmosphere measured. The description of it is measured air pressure. Similarly, it measures AQI pollutant, etc. So for example, in case if I want to get the latest data of this particular resource, I can say get latest data. It might ask for a certificate if you have one. If not, you can directly get the data. If you hit this data, it will give you the latest available data for that particular resource. Here the case is 1231 on 27th of November, and it gives information such as light, ozone, etc., as per the data model that we saw. Similar to the list interface or the list based queries that we also have a map query. Catalog allows us to query for a particular region using geo based queries such as polygon, bbox, and circle. I can just do a circle query for any geo region. It should give me the list of sensors available within the region. I can also filter it based on resource groups. For example, if I just want AQM sensors in this group, I can select this here. These information can also be passed as a part of the arguments that we have or the parameters that we have as per the API. Clicking on this will allow me to get either the latest data or temporal data. This would call the resource error interface for getting the latest data for that particular sensor. You are seeing values null here because currently that particular sensor called Bremen square is off. You can see the status is off. Once it is on, you might get all the data as per the other sensors which we saw earlier. Further, in this tutorial set, we'll have a look at the Postman collections that we have, mainly for catalog and the resource error interface, and then we'll go through the parameters that we have as options for these datasets. Let me quickly start with the APIs for catalog. Before going further, these collections are shared to you through the IUDX forum. You can start downloading it. Once you download, you can just import it, and then you should be able to do all the queries that we are doing. Like I explained before, catalog interface allows us to discover resources. For example, if I want to discover all the sensors that is available in the instance called IUDX, which is the Pune Urban Data Exchange, I can just hit the search endpoint without any authentication required, and it will respond back with all the available sensors that we have. For example, if I want to do an attribute based search, I do a search with couple of query parameters called as an attribute name and an attribute value. Similar to the UI, here I am trying to do an API call with the tags called pollution. So if I do a search with an attribute query, I would just get all the pollution tagged resources available in the IUDX instance. I can also combine multiple queries or multiple query parameters, such as asking for a traffic related sensor and a pollution sensor available in Pune. All you need to do is to construct the query parameter as described in our API documentation. I can also do a spatial query like I showed you in the map example, where I provide a latitude value, a longitude value, and a radius in meter. This would respond me with all the available sensor within that particular geo region. Similar to circle, you can also do a bbox, you can do a polygon, and also a line string based search. A special feature that we have here is something called as an attribute filter. In case if you are not interested in all the fields that's been sent by the catalog, you can filter the response requesting for the specific field that you are interested in. For example, I am requesting for all the tags and ID of the resources available in the catalog of Pune. Like for example, here I get the tags called for all the air quality sensor, all the flood sensor, and all the sensors available there. I can also combine this filter with all the searches I am doing. For example, I can do it with the spatial query, I can do it with an attribute query. I can combine the spatial and the attribute query together to build a complex query. This example is one such of kind. I am trying to do an attribute query where I am trying to do a query on the field called tag. I am doing a geo query using a circle, and I am also trying to pass certain filters saying that within this geo region, give me all the pollution sensors, and on the response just give me the ID and tag of it. The response of it will just give me the ID and tag for that particular geolocation. So all these queries are also accessible through the count API. For example, count API will just provide me the count of the number of sensors that is available for this particular query. Like for example, for this geo region, for this tag, I have 5 such entries. So this API would also be helpful for you on understanding the number of sensors that is available within the particular geo query that you are trying to build, or any type of query that you are trying to build, and then construct the resources that you want based on the response. Next, we will have a look at the resource server interface. The resource server interface, as I explained before, has APIs to search and count datasets that is available within a resource server. For example, the search API allows you to get data through temporal queries, through geo queries, and also through attribute queries. One such example is to just get the latest data. To obtain a particular resource ID, the first thing you need to do is to go to the catalog, do a query, or discover a resource that you are interested in, obtain the ID that you have. For example, in this catalog query, we obtained a particular ID here. We use this ID as a body parameter whenever you do a query on the resource server. So for example, I obtained an ITMS related ID from the query which I made to the catalog using the discovery interface of the catalog. I'm using that information here to obtain the latest data for that particular resource. A hit on this should give me just the latest data of that particular ITMS resource. I can also use the temporal query where I can provide a start time and an end time of a particular resource, and based on that I would just get data between that start and end time. I can also add certain options such as provide me just the latest data between the start time and end time for a particular resource. This would just give me the latest sense data between the start time and end time. Similar to the discovery interface through catalog, there is also a count API which will allow you to do the exact thing what a search API will allow you to do. The next interesting API is a spatial API. For example, I can provide a latitude, longitude, and a radius value for a particular sensor which has the lat and long value available as a sensed data for us to do a geo query around it. A query around this will provide me data sets that is pertaining to this region. Once such a data set is available, the resource server will throw us with all the available data set. I can also add certain options, like for example, give me just the latest data for this geo query. This will allow me to just get the latest data for this particular geo query. Similar to the catalog, the resource server will also allow you to do query based on a polygon, a bbox, and also a line string. On top of it, it also has something called as an attribute query. For example, I can do an attribute search where I can say the attribute which I am looking for is light, and the value of the attribute which I am looking for should be greater than a particular attribute value. So we have a comparison operator for an attribute query which could be, say, greater than, less than, equal to, not equal to, things like that. With this, we can just get data sets that are actually falling to this particular query. You can also construct complex queries such as combining a geo query with a temporal query, or combining a geo query with an attribute query, or a geo query with a temporal query and an attribute query as shown below. So for example, in this API, I'm trying to use the resource server capabilities as much as possible. For example, for this particular ITMS resource, I'm doing a geo query, I'm giving a temporal query, I'm giving an attribute query, and I'm also giving an attribute filter. along with which I am asking just give me the latest data available for this query that you have, and the server will return back a particular data set. Here it is 14th of November because the start time and end time which I am querying is between that range. Apart from the query feature and the search and discover API that the resource server has, there is also something called as a download API. Using download API, you can request for the downloads available for a particular resource. To obtain this download link, all you need to do is to go to the catalog, search for a particular resource server group. For example, if I want to get the downloadables available for an AQM Bosch Climo, I go to this resource server, get the resource server group. I go to the catalog, search for maybe a pollution sensor, get the resource server group to which it belongs to. I put that information here and I call this API called download with an options called all. Once I send this to the resource server, it will give me back with the download URL. This URL is basically a link to a Google Drive. For example, if I want to open this up, I would get to know how the data is being orchestrated there. Here I have data for basically week number close to 18 to the current week. The data available in this download section is categorized as per the week of the year basis. So whenever you want to download this data set, you just keep this in mind. Every file is accumulated at a weekly basis, so you can construct some sort of a script to maybe take all these downloads and then stitch it together, things like that. Overall, these are the available APIs basically for the resource server and also for the catalog. I just want to let you know again, these scripts and the Postman collection will also be available in the forum. You can just download these scripts and try it out. In case of any further queries, do write to us in the forum, and also in case if you want, you can also contact us through email.
IUDX is a Python SDK for IUDX, which makes it easy to access smart city resources, meta information, and their live dynamic information. I will walk you through a Jupyter notebook which demonstrates an air quality monitoring application enabled through PyIUDX. Installing PyIUDX is simple and done through pip. Once installed, you can use the catalog module to connect to an IUDX compliant catalog. You can filter for air quality monitoring resources through a tag filter, and you may also specify a ID filter and obtain only the IDs of such air quality monitoring resources. You can filter for all air quality monitoring resources around a certain point and a radius and obtain only those items. PyIUDX provides an items module which combines meta information from catalog and the dynamic live information from resource servers and makes it accessible through a single point. Let's continue as we did before and filter out air quality monitoring resources at a point and a radius and obtain only their IDs. We can pass these IDs to the items module and access meta information and live information from the AQMs object. Once we have initialized the AQMs object, we can plot their locations on a map. As previously explained, every item is based on a data model. The data model explains meta information more clearly. The data model for an air quality monitoring resource is as shown. The air quality monitoring resource has quantitative properties such as air pressure and air quality index and CO2 max and so on. These quantitative properties are measurable properties which can be plotted. In addition, there are also properties which are not measured properties, and in this case it is category, which is a quality indication. And the data model also describes geo properties, which are properties of a spatial domain. As you can see, the data model also has useful meta information such as the description of that quantity, the unit code, and the unit text. Let's use these properties in PyIUDX. Accessing them is as simple as asking for that particular property. Let's find out all the quantitative properties that an air quality monitoring has. and these are the quantitative properties. We can ask all the attributes that a quantitative property possesses. This will query the data model of that particular quantitative property and explain all the attributes that are available as shown. In addition, we can also ask for that quantitative property's description and its symbol. Now, for all the previously filtered air quality monitoring units, we can ask for the latest data by calling the latest function. Once this function is called, the quantitative properties of that item will be populated by querying the resource server. We can also query for a time series data by specifying a start time and an end time to the during function, and we can display the PM10 max value for one such air quality monitoring station. By using this, you can dynamically generate a plot with very little hard coding. And because we queried all the air quality monitoring units around a particular region, we can also iterate over them and plot all their values in a single plot with very minimal amount of coding. This allows us to generate beautiful contour plots as shown with very little coding.